So students, today we are going to continue our chapter surface chemistry, and today we have to discuss the functioning of enzyme, how the enzymes work. Right students? So let's start students. The functioning of enzyme, or you can say that mechanisms of enzyme. See students, see here, I can explain with the help of this given diagram. Here, enzymes which are called as biocatalysts reacts with substrate and give the product in the form of enzyme plus product. In between, intermediate state is formed which is called as enzyme substrate complex. Right? So, let's discuss how the enzymes work. Students, first of all, enzymes and substrate combines with one another like a key and lock mechanism, and when they fix together, join together, the enzyme transfer its message to the substrate, that is the reactant part, and after getting the message, this substrate is going to change into product. As we all know, enzymes are biocatalyst, so it remains as such, right? Now, in the form of chemical, how the enzyme combines with substrate, how the message is transferred, let's start discussing. See students, in enzymes there are number of different shapes, and these shapes having different functional groups like amino group, acetic acid group, and hydroxyl group, thio group, right? These are actually the active centers in the surface of enzymes. And in a substrate, they are having complementary shape and having the functional group which are going to form bond between enzyme and substrate. There will be formation of type of bond like hydrogen bond, intermolecular force of attraction. By these forces they join together, and after joining, the enzyme transfer its message to the substrate, and then production of products is started, right? So in first step, binding of enzyme to the substrate to form an activated complex. In this activated complex, enzyme is going to form a chemical bond between enzyme and substrate. In a second step, there is a decomposition of activated complex into product and changes into enzyme plus product. Here in this table, number of reactions are discussed. In this industrial processes, the catalysts are required. By the use of these catalysts, the reaction becomes fast, rate of reaction enhances. So students, please learn these catalysts of the industrial processes. So students, next move to the another topic that is a very important topic of this chapter, or you can say that now we are going to discuss second half of the chapter. So students, here in our lower classes we have studied that the three types of solutions are there. First of all, the solution is true solution, then colloidal solution, and suspension, right? We all studied this topic in class 9th. They are characterized into true, colloidal, and suspension on the basis of their particle size. The particle size of colloidal solution lies in between true and suspension, greater than true and less than suspension. So here the whole chapter depends upon or going to discuss colloidal solution. So students, the particle size of colloidal solution is 1 to 1000 nanometer, right? Now we are going to discuss the classification of colloids. Students, here our colloidal solutions are classified into three major categories. Number one, physical state of dispersed phase and dispersion medium. Second, the interaction between dispersed phase and dispersion medium. And third, the type of dispersed phase. So first of all, we are going to discuss what is dispersed phase and what is dispersion medium. In a solution, we have studied that we have two types component are there. Number one is solute and number two is solvent. Same in a colloidal solution. Again, they are two major components. Number one, dispersed phase, and second is dispersion medium. Dispersion medium is a solvent and dispersed phase is solute. So, we are going to discuss the classification of colloid on the basis of physical state of dispersed phase and dispersion medium, right? Physical state means solid, liquid or gaseous state. So in this, we have to discuss this topic in tabular form. So in this first topic, it is written as solid dispersed phase, solid dispersion medium. That means solid dissolve in solid. Solid dispersed phase and dispersion medium is liquid. That means solid dissolve in liquid. Next is solid gas. That means solid dissolve in gas. The another one is liquid in solid. Next, liquid in liquid, liquid in gas, gas in solid and gas in liquid. So, we have to study here with example. Like in our paper, the question is asked, write down the any example of sol, give any example of gels. So, we have to know what are the components in sols, right? Sol. Here, solid dissolve in liquid. We have to give the example of that colloidal solution in which solid dissolve in liquid. And when it is asked gel, so the word is gel, but we are learning like this, gels. This will give a great help to learn dispersed phase and dispersion medium. Learn like this, liquid in solid, right? Emulsion means liquid dissolve in liquid. Water in milk, oil in water, they are all emulsions, right? And here the word is used as solid sol. Solid sol, that means here we have to discuss like this, solid sol. Here the component is solid in solid. If it is said aerosol, that means the dispersion medium is air and dispersed phase is solid. If it is asked alcohol, that means alcohol is your dispersion medium, right? So by this way we have to learn dispersed phase and dispersion medium, and we have to get ready with examples. Like in your paper it may be asked, smoke is an example of which type of colloids, and what is dispersed phase and dispersion medium in smoke. So we have to discuss here smoke. As we all know, the dust particles are suspended in air. So solid in air. So it is the major dispersion medium is air. So it is called as aerosol, right? That is all about the classification based on physical state of dispersed phase and dispersion medium, right? Like they take the another example, paints. In paints, solid dissolve in liquid. So It is sol. As we all know, in sol, dispersed phase is solid and dispersion medium is liquid. So, next move on another classification of colloids, that is classification based on nature of interaction between dispersed phase and dispersion medium. See, we have to study that what type of interaction is present in dispersed phase and dispersion medium. See, if we are going to dissolve dispersed phase into dispersion medium and they are forming a colloidal solution, that means they having the particle size in the range of 1 to 1000 nanometer. So there are two types of type of colloids. Number one is lyophilic and number two is lyophobic. When no extra efforts is required to form a colloidal solution, when dispersed phase dissolve in dispersion medium, is called as lyophilic colloids. But when extra force is required to dissolve dispersed phase into dispersion medium, that colloids are called as lyophobic colloids, not lyophilic colloids, and they are irreversible. Once they are formed, they cannot be revert back. We cannot revert back dispersed phase and dispersion medium separately, right? So move on to the another classification of colloids, that is our classification based on type of particles of dispersed phase. Only we have to classify on the basis of dispersed phase. No discussion about dispersion medium. We have to discuss only the particle size of dispersed phase, right? It is classified into three main categories: multimolecular, macromolecular, and associated. So we are going to discuss one by one. I am again repeating. Number one is multimolecular, second is macromolecular, and third is associated colloids, right? So we are going to discuss first multimolecular colloids. See, in this, large number of atom, molecules or particles collide together and to come under the range of 1 to 1000 nanometers, and this type of colloidal solution is called as multimolecular colloids. That means their particle size is less, but when they are colliding, when they are collecting one another, when they are aggregating and forming the particle size in the range of 1 to 1000 nanometer, they are called as multimolecular colloids. And the best example is gold sol, or the example sulfur sol, right? Next is macromolecular colloids. Student, in a multimolecular colloids, large number of particles, for example, starch, cellulose, proteins and enzymes. These are macromoleculars. Their size are big. But when they are dissolved in a particular solution and break down into the small size and the particle size in the range of 1 to 1000 nanometer, they are called as macromolecular colloids, right? Next is associated colloids. It's very important and number of time it is asked in your paper. So let's start discussion. See students, associated colloids, there are substances which when they are present in low concentration, when they have the little amount, they are acting as a normal electrolyte. But when the higher concentration is used, then they exhibit colloidal nature. That means they aggregate and give the formation of particle size in the range of 1 to 1000 nanometer. This is called as associated colloids, and this association and this behavior is also called as micelles. See, and the temperature above at the you can say that the particular temperature when this process is happening, this is called as Kraft temperature. And the concentration is called as critical missile concentration. Right? So, we are going to discuss by taking the example of soaps, mechanism of micelle formation. See student. So, we are going to discuss micelle formation. See students, as we all know, see soap particle having two regions. First is hydrophobic and second is hydrophilic portion. So hydrophobic portion is the tail portion and hydrophilic portion is head portion where your functional group is present. So when we are adding in small amount, the head portion, hydrophilic portion is interacting with the water and the tail portion remains outside. But when we are adding in a high amount, greater amount, they forms micelle. That means they aggregate together and forms a ball-like structure in which your hydrophobic and hydrophilic portions remains together. Head portion is outside and inner portion having the tail portion, which is the organic particle which is not interacting with water, and that aggregation is called as micelle formation. Initially they are not forming, see in a beaker, they are not forming aggregate, they are not acting as a micelle, but when we are using high amount, they are forming ball-like structure in which they are aggregate together, and that structure is called as micelle formation. By the process of discussion of micelle formation, we also have to discuss here cleansing action of soap. So students, let's start and going to discuss the cleansing action of soap. See student, as we all know, when we are using soap for cleaning a cloth, there is a dirt particles or a grease particle that are stick in clothes. So initially this is the dirt portion, grease area on the cloth. When we add this soap solution to this soap solution forming covering outside the grease area and forming ball-like structure. So the dirt is locked inside the micelle, and when we are using any force to wash this area, this micelle coming out from the cloth, and this will help to cleaning clothes. So students, that is all about our today's topic. In this, we have discussed the colloidal solutions are classified into three major categories. Number one, on the basis of dispersed phase and dispersion medium. That means it is on the basis of physical state. Number two, in the interaction between dispersed phase and dispersion medium. And third, only on the basis of particle size of dispersed phase. In this, we have discussed the cleansing action of soap in associated colloids. So, students, thank you for listening.